Hello again, and welcome back. This is the third in a series of videos that are designed to help users of the SUM breast cancer cell line knowledge base make use of the data mining tools that we built and launched onto the website. Last time we talked about the gene query tool, which leverages basically all of the data, amplification, overexpression, mutation, and analyzes it with respect to the gene essentiality data obtained from the screens. Today, I want to talk about the first tool we actually built for this, and it's really still my favorite, and it's an incredibly fun one to use. But it's one that I think a lot of people haven't made much use of. And it's called the KEGG Pathway Engine. Now, the motivation for originally developing the KEGG Pathway Engine came from our own work in the lab where we performed the genome scale shRNA screen on our SUM lines and a few other cell lines. And these are powerful screens that tell you about the relative essentiality of every gene essentially in the genome for any cell line. But what was frustrating to me about that, the data that came from those analyses is that what you're left with is essentially a gene list. And, you know, a gene list of roughly 1,000 genes or so, which is kind of unsatisfying, especially given all the work that's done to generate those gene lists. And so in order to avoid people just simply scrolling down and looking for their favorite genes, I wanted there to be a way where the entire list of essential genes could be interpreted in some biologically meaningful way. And so the idea then was to develop a software tool that would basically take the screen data and map them onto any KEGG pathway. And that's what the KEGG Pathway Engine does. So I want to just show you, how fun this is and how enlightening it can be when we are thinking about our work with breast cancer cell lines. So I'll share my screen and we'll begin taking you through this. Okay, so again, I'm going to start with the KEGG Pathway Engine that's here for these additional 50 cell lines, and then we'll talk about the engine for the SUM lines, even though the SUM line KEGG Pathway Engine was developed first. So you can see in this paragraph, it just says the engine maps the genes that were hits in the functional screen onto any KEGG pathway. And then again, you can use CRISPR data or RNAi data. You can also use gene expression data. It's really a fun thing to work with. Okay, so the first cell line that comes up in the drop-down menu is this AU565, which, as I mentioned in a previous video, this cell line was derived from the same patient from which came SKBR3, which is sort of the most famous ERBB2 amplified breast cancer cell line in the literature. So this is an ERBB2 amplified cell line. So a KEGG pathway that would be of interest is the ERBB signaling pathway. So you just type in and it pulls it up. And okay, so now we're going to look at the ERBB signaling pathway for AU565 cells. What you're going to see right away is you get sort of two returns when you do this. The first is the actual KEGG pathway map for the ERBB signaling pathway. And in this map, what immediately jumps out at you are the red boxes, which shows you the genes in this screen, in this cell line, that were hits in the screen. And of course, since this is an ERBB2 amplified cell line, you won't be surprised that ERBB2 was a hit in the screen. You might not be surprised that ERBB3 was also a hit in the screen. ERBB4 was not. EGFR was not. So this is an ERBB2 amplified cell line where it appears that ERBB2, ERBB3 signaling is pretty operative. And then some downstream genes that are active, GRAB2, STAT5, PI3 kinase. We've talked about this before in the context of ERBB2 signaling, this little theme that will keep coming back. So PI3 kinase is a hit in the screen. And then a few other genes, FAC, MYC, not too surprising probably. Some things in the mTOR pathway, mTOR itself, EIF4EBP1 hits in the screen. So you can So now instead of just having, a list, you can put some of these essential genes in some sort of biological context. Now, when we first started this, all you got was the map. So we wanted to have the tool work in a way where you could actually now see the actual data associated with each of these genes. So what you have now in the table is over these 9 pages, every gene that maps to this pathway is listed here. And now they're rank ordered, in this case, by the CRISPR score. And if you want them rank ordered by the shRNA score, you can do that as well. Or if you want them rank ordered by log fold change or DNA amplification, you can do that too. And so the reason that as a starting point, we have them rank ordered by the CRISPR score is so that it's easy for people to move back and forth between the picture and the data. So, and this is important. So for example, because some of these pathways are a little generic. So here it shows PI3 kinase was a hit in the screen. Well, that's okay, but which PI3 kinase? As I mentioned in the previous video, there's 3 different classes and a bunch of different isoforms. So which one was a hit? Well, now this is where having the data come in handy, because you can see that in fact it's PIK3CA. You can see that PIK3CA was not mutant in this cell line, but it was a strong hit in both the CRISPR screen and the RNA interference screen. So this tells you that, ERB2, ERB3, PIK3CA, mTOR, MYC, all strong hits in the screen. This is an interesting gene called Crackle. Here's the GRAB2 that was a hit in the screen, EIF4ABP1, et cetera. So you can not only see visually where the screen hit genes lie in with reference to the map, but you can actually see all of the data associated with them. And I think that's really important. Now, the other thing you'll see is there's 3 radio buttons here. So the first map that comes up is based on CRISPR screen data. If you want to see the map based on the RNAi or shRNA screen data, you merely click the button. And it's a slightly different map. You see ERB2 just missed the cut actually of that -0.5. ERB3 is still a hit though. PI3 kinase is still a hit. Now this AKT is a hit, mTOR, and so forth. So a lot of overlap. Your AKT, this is interesting because AKT1 is now a hit in the RNAi screen, but it wasn't a hit in the CRISPR screen. Not sure I can explain that, but this is one of the reasons it's nice to have both sets of screen data. It's not surprising that AKT1 would be a hit in the screen. It's expressed at a relatively normal level, so that's okay. And so, you can toggle back and forth and again, get a visual picture of the hits in the pathway, as well as see the actual data and decide for yourself whether you think the gene is essential or not. And then on top of that, and this is a really cool feature, you can click the gene expression button. Because again, gene expression data for all the cell lines are in the database. And you can very quickly see the genes that are overexpressed. And you can see now EGFR is actually overexpressed in this cell line, even though it wasn't a screen hit. ERB2 is overexpressed. ERB3 is expressed at normal levels. EGF is actually expressed, and some of the other ligands are underexpressed, and so forth. So you can, again, very quickly either just see visually the genes that are overexpressed or underexpressed, or you can see by log fold change. And in this case now, you can actually rank order them. Again, like you can do all of this, you can rank order by log fold change. And not sure why that's not working very well here. Again. All right, well, there's a bug. Okay. So anyway, you can look for these genes and identify the ones that are overexpressed and underexpressed. Okay, let's choose another cell line that is really a really interesting cell line. DU4475, which a lot of people don't work with. And in fact, this is a cell line, as you'll see in probably the next post, is interesting because its driving oncogene is a BRAF point mutation, which is not common in breast cancer, obviously. But it makes the MAP kinase pathway pretty interesting for this cell line. And so we're actually going to go to, let's go to the CRISPR screen data. And so now here's the MAP kinase pathway. And again, not terribly surprising for a cell line with an active BRAF oncogene. Here's that part of the MAP kinase pathway, and it's really lit up like a Christmas tree. Here's BRAF here. Here's ERK, so the downstream signaling molecules. Here's RAS. There's some growth factor and some receptor tyrosine kinase that are driving signaling through this pathway in this cell line as well. So again, if this is all we had, it's a little unsatisfying. So, but now by looking at the data, we can really dig deeper into this, and we can see that here's BRAF, here's the classic V600E mutation. That's 15,000 times cosmic, and a very strong CRISPR score. So this is a gene that's point mutated and is absolutely essential for the cell line. And you can get a sense for some of the other cells, some of the other genes that are important as well. Again, MYC was a strong hit in the screen here. Here's PDGF receptor alpha, which corresponds to this receptor tyrosine kinase. So this is the RTK that was a hit in the screen. That's kind of surprising, right? We don't really see that very often in breast cancer. Here's an aspect of this that is really fascinating when one begins looking at some of these pathways. For many of these cell lines, we often see that RAS is a hit in the screen, but again, which RAS? Well, it turns out in this case, it's KRAS. So this is a breast cancer cell line driving through BRAF, but signaling also through KRAS, which is a significant hit in the screen. And again, it's the kind of thing that one can identify using this approach, which is really pretty fascinating. So this is a good example of how you can use the KEGG Pathway Engine to investigate specific cell lines, specific pathways based on, again, a gene you're interested in, or an oncogene, or if you're just interested in the pathway itself. Let me give you another example of that. So let's switch over now to the SumLine KEGG Pathway Engine. And again, this was the original tool, the first tool we ever developed for this knowledge base. And the first line that always comes up here is SUM149, which again is one where there's a lot of EGFR signaling. So let's do ERB signaling again. Now here we only have shRNA screen data. We haven't done CRISPR in our lab. And again, what you see, a lot of ERB1. ERB1 was a strong hit in the screen. ERB3 was a hit in the screen again as well. GRAB2. In this case, GAB1, which is the link to PI3 kinase. And again, one can ask, well, which PI3 kinase? And I think, well, let's go to, it's PIK3R2, actually, that's responsible for that red box. So this is the regulatory isoform, the R2 version, that was a hit in the screen, and it was a pretty good rank at 768. And then now, and again, this has happened before. Here's RAS lighting up here. It's NRAS. NRAS was the RAS family member that was a hit in the screen. This is not uncommon. I've seen this several times as I've looked in this pathway for a number of breast cancer cell lines. And we don't think about it in this way. We just always think it's HRAS, and sometimes different cells actually signal through different RAS family members. So once again, ERB3, a pretty little bit close to the border, but a hit in the screen. And again, now you can scroll through, and this is now rank ordered by the quant log rank, and you can go from top to bottom, and you can see that BRAF was not very active in this screen, as you would expect. You can work your way down here. PIK3CA was not a hit in the screen. Again, it's not an ERB2 amplified line. It's not a PIK3CA mutant line. So PIK3CA is not necessarily the most important isoform here, and you can see by scrolling through that data. Now, if we look at gene expression in this cell line, we can see that there are some overexpressed genes. TGF-alpha is overexpressed. Amphiregulin is actually overexpressed in this line as well. Epiregulin, beta-cellulin and some genes that are underexpressed. BRAF is expressed at pretty normal levels. Okay. Okay, so that's sort of generally how you use this pathway engine. It's very useful if you know a gene you're interested in maps to a specific pathway. If you don't know which KEGG pathway your gene of interest maps to, you can just simply go to the KEGG website and type it in and it'll tell you. And oftentimes genes map to multiple pathways and then you can just sort of dial those in and see it that way. In future versions of the website, I think we'll have a hot link that will go right to that and make that a little bit easier for you. Now, many people aren't terribly familiar with KEGG pathways, and so almost don't know where to start here. Or as we talked about last time, they might become interested in a particular KEGG pathway and don't know which cell line to use or not use when it comes to exploring that pathway further. I'm going to show you another feature that we developed, which currently is only available for the some lines, but soon will be available for the rest of the lines as well. Okay, so we have, in addition to the KEGG pathway, and by the way, there is a tutorial on this online that you can watch as well. We have this KEGG pathway, this one here, this KEGG pathway analysis tool. And so what this tool is designed to do is allow users to either, for the cell line they're working with, identify the most important KEGG pathways by enrichment of screen hit data to those pathways, or alternatively, decide on a pathway they're interested in and identify the cell lines for which that pathway is most and least important. And so that was the idea behind generating this tool. And you know, one of the things that that I was first surprised to find using this tool, and it was really interesting, is people were becoming interested in the Hippo pathway, for example. There's a lot of excitement about Hippo signaling. So if you do this viewing by pathway, you can now click on this, and now you can, all the KEGG pathways are in here. You can just scroll down and find Hippo signaling, Homo sapiens. And what you notice right away is the cell line that comes to the top is some 185, and the one that goes to the bottom is some 190. And you get a rank within the cell line, and you get an enrichment score. And so this shows at some 185, there's a lot going on with regard to Hippo signaling, but very little going on at some 190. So now, knowing this, you can go back to your KEGG Pathway Engine. You can dial up, you can now pick some 185. You can now pick Hippo. You can now just type this in. And presto changeo, the pathway comes up and you can see how this lights up. How many genes that map to the Hippo pathway are essential in some 190. And there are some really interesting ones, including E-cadherin, alpha-catenin, TCF-LEF, YAP-PAS, and so forth. Downstream targets of these Hippo-specific transcription factors, CTGF. And again, once again, you have access to the data, rank ordered by screen hit rank, and you can see this TCF7 is really hot in this screen, even though it's not expressed for high levels, but it is a transcription factor, so you don't mind that too much. CDH1, like a lot of real breast cancers, not those EMT ones, but real breast cancers often overexpress E-cadherin. SUM185 is one of them. There's a whole subset of breast cancers that overexpress E-cadherin. This cell was derived from a pleural effusion metastasis. So these are highly invasive, aggressive cells overexpressing E-cadherin that maps to this pathway. Again, YAP here was a strong hit, and here's alpha-catenin. So you can see right away the genes in this pathway, and you can see why it had the highest score, because it really, really lights up. Now, by contrast, as we saw in that other tool, SUM190 had the lowest score for Hippo signaling. And, there you go. It's essentially cold, and most importantly, nothing in here lit up at all. And so, if you're interested in Hippo signaling, SUM185 is a good cell line to study as one where that pathway is highly essential. And by contrast, SUM190 is a cell line where it's not essential. And interestingly, because SUM190 was derived from an inflammatory breast cancer, it too has a lot of E-cadherin, which is a hit in the screen. And so again, E-cadherin is kind of a bad reputation. Don't get me started on it. But it was, once again, it's overexpressed and was a hit in the screen. So again, here's an example of where using that tool can help guide you to pathways and so forth. I want to take you back to this one, because I want to just show you, using this analysis tool, some interesting discoveries. So, one of the things that, I'm going to keep it by pathway for now. A lot of people are interested in TGF-beta. And when you look at the TGF-beta signaling pathway, here comes SUM229. Now, this is really interesting, because SUM229 is a very aggressive KRAS mutant cell line. You'll see more about that later when I do the oncogene signature tool. This is a KRAS mutant breast cancer cell line. So it's obviously a very, very aggressive cell line. And it has the highest score for TGF-beta signaling. And so, okay, well, what's going on there? So again, back to the pathway engine we go. And we're going to look at the TGF-beta signaling pathway in SUM229. TGF-beta signaling. And I was shocked when I saw this, I have to say. And again, so in using this tool, I learned something about my own cell line that I really didn't know very much about. So what you find here is that TGF-beta is a hit in the screen, and TGF-beta R2 is a hit, and a SMAD is a hit. So whenever you see this, 3 genes in a pathway that are directly linked to one another, and they're all hits in the screen, that's pretty strong evidence that this pathway is pretty active in this cell line. So again, if you're interested in TGF-beta signaling, you need to be working with SUM229, because this is where the action is. In addition to that, a bone morphogenic protein receptors here, and activin is a hit in the screen, as well as some of these downstream players as well. And again, as with all of this, you have now the opportunity to see the data. So, okay, if TGF-beta is a hit in the screen, well, which one? Well, it's TGF-beta 1. That was a strong hit in the screen. It's slightly overexpressed, not a big deal. RBX1 is a hit, SMAD3, ranked number 38 out of 1,000 in terms of being a hit. It's slightly, but significantly overexpressed. TGF-beta R2. So here you go. TGF-beta 1's a hit in the screen. TGF-beta R2 is a hit in the screen. SMAD3 is a hit in the screen. CDKN2B is a hit in the screen. And these things are all linked to each other. Here's the inhibin right here. This is a cell line for which there is an awful lot going on in this pathway. And as a result of some of these findings, we were also interested in what Wnt signaling looked like in this pathway. And again, so now you can look at that very, very quickly. And lo and behold, there's a lot of Wnt signaling. And one of the reasons we wanted to look at Wnt signaling is because, again, this is a KRAS, a mutant cell line. But again, as you'll also see in a later post, these cells have a point mutation in APC. And I showed you before that TCF7 was a strong hit. So here we have now a frizzled receptor, a hit in the screen, beta-catenin, APC, TCF-LEF, and this TGF-beta signaling pathway directly interacts here by this SMAD. So this is a really interesting cell line that really, before I did this, I knew nothing about it other than the fact that it had a KRAS mutation. It wasn't doing anything else that I was used to seeing in breast cancer cell lines, because again, there are not a lot of breast cancer cells with KRAS mutations. But by exploring using the KEGG Pathway Engine and the analysis tool, I was able to identify this cell line as one where the action is really all in TGF-beta and Wnt signaling. And so that's where the Achilles heel of this cell line is in fact likely to be. And since I'm on the subject of Wnt signaling, which has sort of always been a favorite topic of mine, there's another cell line that we developed, which has also been sort of mysterious. It's a highly aggressive, spontaneously metastatic line called SUM1315. And again, you see the same thing. Wnt, frizzled, beta-catenin, TCF, LEF, a SMAD. And so this suggests right away that these very basal, claudin low, highly malignant, highly aggressive breast cancer cell lines are signaling through TGF-beta and Wnt signaling, and that these are really the predominant signaling pathways for these cells. Again, had I not developed these tools, I would not know this about these breast cancer cell lines. And I think that becomes some of the most powerful reasons to use this, because you can toggle back and forth between tools and find things that you've really never seen before. And again, if I just look at Wnt signaling now, I see, wow, even SUM185 has got a lot of Wnt signaling. Here's SUM229. So they come pretty high up in the list. And other cell lines, there's really nothing going on in Wnt, as you might or might not expect, but you can actually see which genes hit in the screen that map to this pathway. So I just want to close by showing that you can switch this off and you can go by cell line. And you can say, okay, SUM44. What are the best, the most active and the least active pathways? Well, in most of these cell lines, RNA transport is going to come up very, very high. A lot of common essential genes in here. So not too excited about that, but I was interested in purine metabolism, PI3 kinase, AKT signaling, cell cycle. Of course, pathways in cancer always comes up, proteoglycans in cancer. And so once again, you can sort of say, okay, well, that's interesting. What genes are most interesting? If I take SUM185, which is a really interesting one, the MAP kinase signaling pathway, PI3 kinase, comes up next. And then again, you go back to the KEGG Pathway Engine and you look at PI3 kinase signaling in SUM185 cells to find out the exact genes in that pathway that gave rise to that high ranking. And again, you learn more about the cells you work with. SUM185, click and backspace, PI3, AKT signaling pathway, and again, you won't be surprised to see this pathway just lights up like a Christmas tree. And with a growth factor, a receptor, GRAB2, SOS, RAS. Which RAS? Let's see. A lot of pages of hits here. We're still not there. Yeah, the cell line had a lot of hits in the screen. Wow, a lot of hits. All right, well, I'm not finding it right away, but oh, I'm sorry, I was right on the first page. It's NRAS right here. So NRAS, again, very strong hit in the screen, ranked 17. BCL2L1, this gene is actually amplified and overexpressed. It was ranked number 5 hit in the screen. It's part of the oncogene signature. Here it is right here in the pathway. all kinds of stuff going on in here. PI3 kinase, some integrins are lighting up. This, of course, this cell line is an amplification of FGFR3 that maps here. That was a strong hit in the screen. Again, a lot of mTOR and so forth going on here. So this is a cell line where the PI3 kinase pathway is really hot, to be expected because of the FGFR amplification, the BCL2L1 amplification, and I think this has a PIK3CA mutation as well. And just to give you a contrast, because some people think, well, PI3 kinase, it's important in every cell line. If you now just scroll down and say, look at 1315 for the same pathway, where TGFbeta signaling was important, this thing is ice cold, right? So you would never want to use this cell line to study PI3 kinase AKT signaling unless it was your sort of control for a cell line for which this pathway is pretty inactive. And so again, this tool allows you to very quickly identify the important players, but the cell lines and pathways that sort of go together. And again, you begin to really learn a lot about these individual cell lines as specific models of specific types of breast cancer. And in the blog, Cell Lines Are People Too, that's one of the things I'm trying to sort of convince you of, is that each cell line is a good model of the disease of the patient from which the cell line came, and that no two are exactly alike. And if you look through these tools with these, look through these cell lines with these tools, you'll see that that's true. And that's an important feature about the genomics of breast cancer that I think we have to come to grips with here at some point. Okay, so that was a lot. Again, this is really a fun tool. Just play with it. And again, if you want to talk to me about it, we can do a one-on-one session or send me an email. But I really think if you take a few minutes and just play with this pathway analysis tool, you will learn a lot about cell lines you're working with. Learn about pathways, the genes you're interested in, where they are, which cell lines are important in and not, and so forth. And it will just give context, biological context, to a lot of the work that you're doing. So again, thank you for tuning in. The next video that I'll do will be on the oncogene signature tool. So stay tuned for that. Thanks again, and see you next time.